Functions. Which of the following are polynomial functions? Well, a couple of things. Functions do not have variables. Remember, variables are the letters in the denominator. Or negative exponents. Because if you think about it, if you have a negative exponent, say you have x to the negative third, to correct that, you can't have a negative exponent, so you change it to a positive. Remember, to get rid of a negative exponent, you change its position. So that leaves you a 1 in the top, and when you move that, that makes it x to the positive 3. So this, you can't have a negative exponent, and that you can't have a variable in the denominator. It gives you the same thing, so that's why this is not a function, because it has a variable in the denominator. And if we were to move that x to the fourth, if we were to change that, it'd be x to the negative fourth. It would have a negative exponent. So these are very similar in how they work there. Then the second thing, you can't have a variable under a radical. So no variables under radicals. So right here, now we have to be very careful. If you look right here on this first one, the 12 is the only thing that's under the radical. The x is not under the radical. So that one is good. So this is one. Then let's look at the next one. There's no negative exponents. There's no variables in the denominator. There's no radicals. So this is a good one. This is a function. Then if you look at this one right here, it's the 8 and the x. So there's a variable underneath the radical. So this one is not. So it's just those two. If you did the previous homework, this is just a repeat, the same thing. We're going to find the degree. The degree is the highest exponent in that expression, and we have on the first one 3, 2, and 4, so the degree is 4. That's the biggest number. The leading term is that term that has that exponent of 4, and we write all of it, and the leading coefficient is negative 2. So next row, we have a cubed, a to the 6th, a to the 4th. So the highest exponent is 6, so that's our degree of the polynomial. And then the term that has that is 15, a to the 6th, and the coefficient is a 15. The last one, the highest exponent, is 20. And that is on the term negative 3y to the 20th, and its leading coefficient is negative 3. Polynomial functions, which is what we're looking for right here, are smooth and continuous. Those are the key words. They're smooth and continuous. So there are no sharp turns and no disconnections. So if we look at this graph right here, it's smooth and continuous. So this is one. If we look at this one, it's smooth and continuous. So this is a function. This one has a sharp turn. So this is not, because it has a sharp turn. This one, you can't see, but it goes right here, and then it goes this way. So it has a sharp turn there. It's not smooth, so it's sharp, not smooth. So this is not one. Now, you may also see a graph where it has something like, maybe it has this, and then it starts over here and goes like this. That's disconnected. So that would not be a polynomial function. All right, if both ends of a graph are going in the same direction, notice both of these are going up, that means it's an even degree. If one was going up and one was going down, so both of these are going up, even degree, or if they were both going down, even degree. If one was going, say, up and the other was going down, or if one was going down and the other was going up, so opposite directions, that would be an odd degree. So this one, both directions, so this is even. Okay, here's an explanation. This over here on the left show graphs with even degrees. Notice the ends are going in the same direction. These are both going up, and these are both going down. So that makes it an even degree. Now, they're going to ask about the leading coefficient. Notice if you're pointing up, you're pointing towards the positive numbers. So if it opens up, that's positive. If it opens down, that's negative. So this one is a negative x squared. And it could be x to the fourth, but these are parabola. Then, if you have an odd degree, that means the direction of the ends of your graph are going in opposite directions. Notice this one is going this way, and then the top is going that way. This one is going this way, and then the bottom is going this way. So up, down, down, up. So opposite directions. That means it's odd degree. Now, read the graph left to right. So read left to right. And you can see if you start at the left here and you follow to the other, so say you're following positive route. So that makes it a positive coefficient on our odd degree. This one, reading left to right, so you're starting here and you want to go to the other end. So you're going to the other end, so you're going down, which is negative. So that would be like a negative x to the fifth. All right, both ends are going in the same direction. So ends are in the same direction. They're both going up. So that means it's an even exponent or even degree. And since they both go up, that means it's positive. The leading term is positive. If it were going down, that would be negative. So we have an even, and this is it. Even, and the leading term is positive.